Hello everyone, this is Sanjay from CSIT branch. Today my concept video topic of discrete mathematical structures is forms of compound statement. So we are going to see about the statements and logical forms. First, a statement or proposition is declared to sentence that is either true or false but not both. That means a statement can be true or false, but neither it cannot be true. Like sun rises in the east, it is true, or sun rises in the west, it is false. But this cannot be both true and false. The truth value of proposition is true if it is true proposition and false if it is false proposition. Example, the year 1973 was a leap year is a proposition readily decidable as false. Note the use of label so that overall statement is P is a statement. The year 1973 was leap year, so we use P, Q, R and S and T to represent statement, and these letters are called as statement variables, that is variables that can be replaced by statements. A statement can be replaced by variables with the help of like using P, Q, R and S and T. Determine whether the following statements are not. If it is statement, determine Selangor is a state in Malaysia. Sunrise in the west. So here are some of the examples where we can show that some may be true, some may be false, but this cannot be both are true. Definition: a table that gives the truth values of the compound statements in terms of its component parts is called truth table. Okay, truth table, there are many truth tables are like and, or, if, not. Okay, connectivities. Most mathematical statements are combination of simple statements formed through some choice of words, not, and, or, if, then, and if and only if. These are called as logical connectivities or simple connectivities and are denoted by following symbols. And these are some of the symbols where you can see that the symbol of not is negotiation, and, or, if and only if, then. Compound statements. A statement represented by a single statement variable without any connectivity is called a simple statement. A statement represented by some combination of statement variables and connectivities is called a compound statement. Here we are going to see some of the examples like a dog or a car is an animal. A dog is not an animal. 5 is less than 3. If the earth is flat, then 3 plus 4 equals to 7. Here there are some of the compound statements with a combination of more than statements, and it is connected with the connectivities like a dog or a car is an animal. It is a compound statement. 5 less than 3 is a simple statement. Truth table describes the relationship between the truth values of statement. Truth tables are especially valued in the determination of the truth values of statement introduced from simpler statements. If P is statement, the negotiation of P is not P. If it is not the case, then P is denoted by negotiation P as opposite of the truth value, where P has only two outcomes, that is true and false, and negotiation of true is false and the negotiation of false is true. And here it is an example of give the negotiation of the following words like the integer 10 is even. Negotiation of it this may be the integer 10 is not even. 2 plus 3 is greater than 1. Negotiation of this 2 plus 3 is less than 1. And the negotiation of 3 plus 7 is equals to 10. And this negotiation will be 3 plus 7 is not equal to 10. Definition: if P and Q are statement variables, the conjunction P and Q, where P and Q denoted by this symbol, the state compound statement P and Q is true when both P and Q are true, otherwise it will be false. And here it is the truth table of and it is the and truth table, where one of the outcome is false, then the one of the income is false, then the outcome will be false, where true and true will be true, the other all three of the cases will be false, whereas in true and false, false and true, and false and false. Form the conjunction of P and Q for each of the following, where the P is it is snowing and Q is I am cold. We can join the statement by it is snowing and I am cold. Okay. and here it is having the distinction where P or Q, and this is denoted by this symbol. Whereas P or Q, in this OR truth table, if one of the input is true, then this will be true. The negotiation of for inequalities involves AND OR statements. Read A, B, C, B, particularly real numbers. Negotiation is an unary operation while AND and OR are binary operations. And here are some of the examples where you can see that by drawing the two truth tables. A statement form is an expression made up of statement variables and connectives. The truth table for the given statement form displays the truth values that correspond to the different combinations of truth values of the variables. Truth table for S involves more than two statements, and whereas if there are only two statements, that is true and false, the possible cases are only four. But if the truth table of involving three statements, the possible outcomes will be 1, 2, 3, 4, 5, 6, 7, 8. And here there are some of the examples of construction of the truth table for the statements of P, Q and R. And he will give the statement and we need to construct the truth table. First we are going to construct the truth table for the P and Q, then the negotiation of R, then the AND operation between these two statements, and after that we are going to get the output. And here are the some of the examples of the truth tables. And we are going to learn about the tautology, contradiction and contingency. Tautology is a statement from where its truth values in all rows in the truth tables are always true. Contradiction is a statement from where its truth values in all rows in the truth tables are always false. And a contingency is a statement form that is neither tautology nor contradiction. Tautology means the statements, the truth values in all rows will be always true. And the contradiction is the statements in the truth table is always false. Note T is used to denote the tautology and C is used to denote the contradiction. Conditional statements. If P and Q are statements, the statements if P then Q, P implies Q, and it is denoted by this symbol. It is a conditional. The truth table of P implies Q is, if true implies true, then the outcome is true. If true implies false, it will be false. If the second statement is false, then the second outcome will be false, and false implies true is true, and false implies false is also true. Note: if variable of terminology is used to express the P implies Q as given below. If P then Q, Q if P, P implies Q, Q when P. The hypothesis of P is false, we consider P implies Q is true regardless its conclusion. And here are some of the examples. Negotiation, contraposition, converse and inverse. Otherwise, the negotiation of P implies Q is P or not Q. The contrapositive is P implies Q is not Q implies not P. The converse of P implies Q is Q implies P. The inverse of the P implies Q is not P implies not Q. And there are also biconditional statements where P if and only if is denoted by this symbol, and the truth table of the P double imply biconditional loop, that is P if and only if Q is this one. And here are some of the examples. And these are exclusive OR. And the most important law is De Morgan's law. Here we can see that negotiation of P and Q is not P or not Q. And these are some of the laws which are very tautology and contradictions following logical rules, and these are some of the important laws like commutative laws, associative law, distributive laws, identity laws, negotiation laws, and double negative laws, and idempotent laws, universal bound law, De Morgan's law, absorption law, negotiation of T and C. And these are some of the examples. So today in this topic we learned about the different types of compound statements and also the different root tables of the different statements, and also biconditional statements like and, or, if and only if, implies, etc. Thank you.